Today we'll be going over SolarFarmer and Celestica's integration of SolarFarmer and how to achieve a truly bankable model using Celestica. First, what you need to make sure you do if you'd like to use SolarFarmer is purchase Sol credits. Our Sol credits can be purchased in-app, and what these do is they allow you to use SolarFarmer and our upcoming features such as our 10% interconnection plan sets, consulting services, design services, and whatnot. Each SolarFarmer run takes zero point 0.1 credits, which at the maximum value is $30 and can be as little as $25 right now. So to make a SolarFarmer demo, you do exactly like you make a regular design. You make a project, you can make a design. We'll do a single axis tracker design. And then we'll go to my home state of Pennsylvania because I like designing here. What you can do is you can do a design just like you normally would. So let's just pick a piece of farmland. All right, here's a piece of farmland right here. Looks pretty good. Draw a field. Just doing exactly what you would do to model a normal solar array, right? You can use your design templates to make our single axis tracking generic template, right? All right, that looks great. We want to add now one thing you have to know about SolarFarmer is that it requires PAN and O&D files. So DNV has provided PAN and O&D files to us for representative modules and inverters that you can use. You can go into here and go under DNV and select them. We have 60 inverters and we have, I think, 222 modules. So you can select either these inverters and these modules, or you can upload your custom. If you upload any PAN and O&D file, you can use those as well. One thing to note about the PAN and O&D file upload is we're not saving your PAN and O&D files pre-July 2025. So if you uploaded a custom file before July of 2025, you'll have to re-upload that. That will throw an error. And likewise, you won't be able to run this with any of the generic modules, any of the modules that or inverters from the CEC database. Those don't have all the values that a bankable simulation needs. So right now, with the generic modules that we have on these templates, if I tried to run SolarFarmer, it will give you this error saying, hey, this requires a custom DNV, a custom or DNV verified panel and inverter. The nice thing is DNV is working with us to expand the number of panels and inverters that we have, but for the time being, these are the options you have for running these simulations. So if we wanted to run a simulation, let's use a DNV pan file, and then we'll take a DNV inverter file. These are just selected at random, so that's no harm to the system. One other thing, so like now we'd be able to run it and it will prompt you to use 0.1 Sol credits. But I'd like to go through all of the edge cases first so that you're not confused or worried about why this came up. SolarFarmer does not support a combination of single axis tracking and rooftop system or fixed tilt systems. So if it does, you'll see that, hey, there's a mixed single axis tracking and other project types. You can have pretty much all the canopies, all the rooftops, all the fixed tilt grounds on the same project that you'd like, because those are all fixed tilt systems. You cannot have that in consort with a single axis tracking system. So that will throw an error. Likewise, if you wanted to add a battery to the system, right? SolarFarmer does not allow for batteries. So if I tried to run SolarFarmer again, batteries are not supported, right? So we have to delete that and you'd be able to run it. Yeah, so now how do we make this bankable, right? So one thing that we have to say is, all right, I just designed this array, but what is there? Is this actually a constructible array? So part of this is getting into the nitty-gritty of designs, but let's just check out the wetlands for a moment, make sure there are no wetlands going through. All right, so we're good. There's no wetlands going through. Let's check out the forest canopy height to see what these tree heights are, because it looks like there's trees over here and trees over here, a building and whatnot. There's trees on the inside of the array. one thing to know is that if you don't factor in near shading, you could be off by 10, 20, even more percent of production value because of unaccounted for tree shading, unaccounted for building, and object shading. So it's very crucial that if you want a fully bankable solution, that your first and really the only thing that we haven't handled perfectly for you is to design this array properly. And that's the whole reason you're using us, is the ability to use a quick design tool to model this layout. And so with that, if you want it to be fully bankable, you need to make sure you're adding obstructions as near shading objects. So either you can use obstructions or trees. For the sake of this demo, I'll use trees. So these trees appear to be about 60 feet tall. So we'll do 20 meters and then have a radius of about 10 meters, right? And now what I can do is I can copy these trees over. Didn't want to do that. And I can put it along the edge. It looks like this is probably on the property line. Now, if you're going to be clearing these trees, of course, you don't need to do this, but I'm going to, for the sake of showing you what to do. You can either continue to copy the trees, or you can make an obstruction which is at the same height and just follows that tree line. That will be a lot easier typically, and this will have the same results as just manually placing those trees. And so we'll make that obstruction, put that height at 20, so we're good. And now we have in our near shading scene those shades. Likewise, we probably want to add a couple trees on this side over here. So we can add them here, just on these tips, because they should be close enough that there will be some losses incurred due to them. And then over here as well. Now for rooftops, this includes your HVAC units, this includes any of your obstructions, and then I'm going to do another just line obstruction here. Let's actually get this extended a little past so that we cover all these. Perfect. So now we have our near shading objects in the scene, as well as this layout. Now let's look at the slope. Let's make sure this is something that we're going to build, because we want to get this as close to accurate as possible. I'm going to see if there's anything over 10. There's nothing over 10. So like this could be built close to as is. I'd like to probably add a little bit of an alignment line to fix it to that edge mostly. So let's see how that looks. Yeah, so that's much better of a system. I like how that's looking right there. All right, so now we have a system that you could feasibly build, right? That is what I'm calling, there's 3 different pillars to making a bankable energy model. There's the layout itself. There are the assumptions that you put into the layout, like all of the other things that aren't the layout, that are the losses, the weather file, and so on, and then the model itself, right? Our free model is the NREL System Advisory Model, SAM. That model is very good. It's within a few percentages of SolarFarmer consistently. The difficulty is that banks do not have that as one of their typical models that they're used to seeing. They're used to seeing SolarFarmer. They're used to seeing PVSys. They're starting to get used to seeing SolarFarmer. DNV's banked 2 gigawatts worth of projects through SolarFarmer already, and are on track to do a lot more projects by the end of the year and have that certified as well. So if you use our free model, the SAM model, you can use it. It's very good, super good enough, in line with our competitors for a free simulation tool that gives you very accurate yields. So this is a pretty complex shading scene. You can see that there's 5.4 shading losses, and you can see this is primarily coming from this side because it's going from east to west. There will be not much over here, which is great. There's a little bit right here, which is great. So not too bad shading losses, which means this is a constructible array, right? Like you could, if you wanted to build this, you could go out and build this. You can change some minor things, but the layout is good. And the layout matters because of the type of module you use, type of inverter you use, the road distance, everything in the layout affects the simulation. Now that we have the layout complete, let's go into the easier section, which is the SolarFarmer model itself, as well as the losses. So we'll start with the losses and the assumptions that we feed in to it. SolarFarmer and DNV highly recommends that you do not use NSRDB as your weather file of choice. This is known to have more variance. So variance, that you have a mean of weather files, and then you have, let's backtrack a little bit. Weather files are taken typically off of the past 30 or more years to predict what the next 30 years of weather is going to look like. And then you have a typical meteorological year, TMY, typical meteorological year data set, which is either hourly or sub-hourly, that NSRDB, Solar Anywhere, Solcast, or GIS puts together for you. The difficulty is that IEs have seen that NSRDB's media norms weather files have higher variance than Solar Anywhere, Solcast, or GIS, or one of the paid for weather file providers. So they recommend to not use NSRDB. If you do, you could experience higher than 2%, like more than 2% upcharge, or like higher production than you'd expect from a Solar Anywhere file, from a Solcast file, from any of the other online providers of this. You could also upload a custom file. So say you don't want to use the API integration to go through and pay for that. You could, if you have your own, which you'd like to use, you can upload those customs, and that would also work. The key factor for this is that you can use NSRDB. It's just highly not recommended if you want a fully bankable model. If you do, I'd undercut it by around 2%. So whatever number you get here, you would probably want to take a 2% haircut to that. Likewise, you have these advanced losses, right? So right off the bat, this must be turned on, or you must have your own values coming from a similar model. It will not be considered bankable if you do not use the auto snow and soiling loss that uses a Kimber and Townsend model. If you use 2% across the board, that is not a bankable solution, right? Likewise, you have array losses. Our losses have been verified by DNV on all of our different array configurations. So each array, like a ground mount versus a rooftop versus a carport, are going to have, and likewise fixed tilt versus flush mount versus single axis tracking, are going to have different loss characteristics. And we have verified those loss characteristics with DNV and embedded them within our generic templates. So you can rest assured that all of the difficult part of what are my advanced losses, this is really technical, I don't want to get into that nitty gritty, we've done that for you. As long as you don't change them, and as long as you keep auto snow and soiling turned on, you can rest assured that like second pillar is really ironclad. The only thing you need to do is choose to change from our free weather file to one of the third-party weather files, or upload your own. That is the only user input that's needed to satisfy that second pillar. Now, this third pillar, we've also satisfied for you. So instead of using the system advisor model, you can click on SolarFarmer and run it through this engine. So what PVSys has done for the industry as a whole is it provided an engine that banks felt safe using because it was reliable, they've been using it for so many years, and it was math-backed. The nice thing about SolarFarmer and DNV making SolarFarmer is that DNV works closely with many banks. They exclusively use SolarFarmer for all of the energy models that anybody comes to them to bank with. So if you are using DNV as your IE, they're using SolarFarmer as the model instead of PVSys. Now, why is that important? It's important because SAM, even though it's mathematically accurate, even though it's technically accurate, the banks do not trust it. So the banks trust SolarFarmer, and as this grows in adoption, they're only going to trust it more, just like how they didn't know to trust PVSys when it first came out, but now it's a mainstream design platform. Banks are starting to trust SolarFarmer. It's been around for the better part of 6 years and been in high use in the past 2 years. That is why we integrate it, so that third pillar, that energy model engine, is as ironclad as it gets. It's actually more accurate than PVSys technically. There are a lot of nitty-gritty technical details we can go into, and if you want that, please contact us. We're happy to share those nitty-gritty technical details, but it is significantly more accurate on the string-to-string and module-to-module shading, near shading, and just general shading loss factors, as well as how it takes into account 3D. Now, That's a good point that I brought up. This is a 2D model. This is synonymous with PVSys model. PVSys, even though you see it in 3D, they're actually running a 2D model with that. This is as bankable as PVSys. We currently have the 2D model completely integrated. When we release 3D next year, we will also have the 3D model integrated. That will be a slightly more cost because the 3D model takes significantly longer to run. It's a lot more computationally expensive. But now to get to the good part, right? So we have a good layout, we have good assumptions. Celestica doesn't pay for these, so we're going to keep with NSRDB, but we'd highly recommend you to change this to one of the paid for providers, and then we can run a simulation. So you're going to spend one Sol credit. Here's one thing that is very important is, as we just discussed, that near shading matters. SolarFarmer's 2D model does not take into account object near shading. It takes into account row to row near shading. Celestica has built in our own algorithm that does account for those object to object near shadings. We highly recommend you enabling this so that you do not lose those losses, right? The difference is a 5% higher production if you do not do this. We'd recommend turning this on. The difficulty is once you pay for the simulation, it's a pay per run, right? And so when you confirm and run, the numbers you get are the numbers that are final for this layout for these settings, right? What we do is when we confirm and run, and you'll see that it runs, we lock your ability to change anything in this layout. The reason for that is that if you change anything in the layout, these values are no longer real, right? Because if you wanted to modify this tree, if you wanted to remove some near shading, if you wanted to do anything of the sort, those values will significantly change, right? That is not a good thing. Like, you do not want to be displaying, hey, this is what we're getting versus what we expect. One thing that you can do is, and you can tell you can't modify this, you can't modify these points, you can't delete anything, right? You can't go into here and change anything, everything is disabled. If we go to the project, if you want to copy that project, you can copy it, and now that is disabled. Now, if you wanted to go back into that project, you already have this run, and you can just take this and run. So you can download the 8760, and you can download the report. The 8760 is in TSV format, so this is the exact same type of, this is the exact same file that DNV sends to us, or SolarFarmer sends to us on the back end, and we're giving that to you in a 1-for-1. The last column after grid availability is your final AC out that we'd recommend using. Likewise, we have the PDF. The PDF is pretty much the exact same as our regular PDF. The only difference is that we have this nice powered by SolarFarmer verification at the bottom, so you know that these results are powered by the SolarFarmer model and not by any other model. So going back to it, you can download it. These are immediately accessible and locked for all time. These designs, we'd highly recommend changing the name to say SolarFarmer Run 1, whatever you'd like to do. And this fully wraps up how to create a bankable model using Celestica. The key aspects are making sure that this is a really constructible array, adding in those near shading objects such as trees or obstructions, making sure that you have either a single axis tracker system or multiple fixed tilt systems, making sure that you have your either custom PAN-OND file uploads, which will have to be re-uploaded if they're before July 2025, or using the DNV locally hosted inverter and modules that you can select. The second pillar are the assumptions in the weather file. Please use a weather file that's not NSRDB, and if so, just expect a 2% haircut when you go to the banks. And then use our advanced loss functions unless you have something that can verifiably prove a deviation from it. And then that third pillar is the engine itself. Simply just use SolarFarmer, and you will get that third pillar satisfied. Now, when you take all three together, all three have to be correct and true for you to produce a bankable model. Like we did in this case, this is a bankable model. And we would highly recommend doing this for when you get to late stage development, or pretty much any time you'd like. But given the slightly higher cost, we would definitely recommend doing this once you get a project to that financing stage. You can use this as much as you'd like. Alternatively, you could also download the PVC file to go directly into the SolarFarmer desktop or PVSys desktop app. That is, since we have SolarFarmer integrated, not going to continue to be updated if there are any issues with it. All right, well, now you know how to do a fully bankable model within Celestica using the SolarFarmer integration. I hope you have a great day and are excited to not design in PVSys anymore.